we will now just switch over to nephropathology. So we'll start with the renal pathology. Renal pathology is something they ask you very important in most of your exams. So I'll now start with a nephropathology discussion, because nephropathology is something which comes very often in the questions. So I will exclusively dedicate the discussion on systemic pathology with the kidneys. Not only the kidneys, I am going to cover even the vessel walls also, vascular chapters, mainly vasculitis also. So your discussion in the kidney, that's something which I want you to remember. If I start with the kidney, what are the things you should need to focus in the exam? Basically, you will be asked questions on glomerular diseases. Glomerular diseases. You will be asked questions on tubulointerstitial. Tubulointerstitial. You will be asked questions on vascular diseases. Vascular diseases. But if you ask me what are the important things we need to focus on the exam, very often I will just say glomerular disease, glomerular, because that is where majority, 90% of your questions, kidney questions are from glomerular disease. The last chapter which you need to focus is tumors. Tumors I will try to cover also. Tumors also we will finish off in one single shot in this discussion on nephropathology. So what is this kidney diseases primarily focused on? I want to just remember, kidney is made up of only 4 compartments. What are the 4 compartments? We should know. The 4 compartments are glomeruli. Glomeruli is plural, glomerulus is singular, tubules, interstitium, blood vessels. I want you to just remember these points. Now, can we just identify all these things on the image? It's basically image based questions what you are going to get in the exam. I want you to just focus on the important structures. I will show you this is your glomerulus. This is your tubules. The rounded structures what you see here, this is the tubules. In between the rounded structure, you see some small space. That space is called interstitium. Can you see these blood vessels? This is your afferent and efferent blood vessels. So we get to see all these structures back in your kidney. So I wanted to just start looking at your pictures and also to emphasize your questions. So we will be focusing mainly on the approach. I will give you an approach before we start our discussion. The approach is something which we will get in the exam. Once you are very familiar with the approach, how do we approach these renal questions, then we will get into the questions very easily. Now, what is the first important thing is we should be familiar with light microscope. Findings. For any glomerular disease, you should know about light microscope findings. Second one, you should know about immunofluorescence finding. Immunofluorescence findings. That's the second important thing they ask you. Is it IgG positive, IgM positive, IgA? So that is something you should be familiar with. Third thing, you should be familiar with electron microscope finding. Electron microscope findings. Fourth one, you should be familiar with finally the clinical features of that particular glomerular disease. Now, how do we make a diagnosis? If you want to make a diagnosis, you need to summarize all these findings into a final thing as final diagnosis. It is not for your exams alone we say this final diagnosis based on these 4 findings. Even on a routine reporting, when I see all renal biopsies, I have these 4 stage approach. I will look at the biopsy and see for light microscope changes. I will look at the immunofluorescence and I will have some findings on that. I will have electron microscope. Electron microscope means you say subepithelial deposits, subendothelial deposits, membranous deposits, intramembranous deposits, mesangial deposits. That is called electron microscope finding. Then finally, I will say clinical features. What is the clinical feature of this patient? Does he have nephrotic syndrome, nephritic syndrome, RPGN, or is having proteinuria as a manifestation, or is having small subnephrotic range proteinuria, hematuria for evaluation. So, I need to know the clinical features. Once you know the clinical features, you are now done with the diagnosis. So, the entire thing is based on the glomerular disease, based on the biopsy. Even when you start working in nephrology, most of the times the nephrologists are not the one who say membranous, FSGS or minimal lesion or membranoproliferative. It is the pathologist report which tells you all these things. So, that is why it is most often pathological diagnosis. So, how do we make a diagnosis? You should be familiar with the biopsy. So, I am just going to simplify all these things into very simple one, the biopsy, renal biopsy. The renal biopsy is usually put in a small fixative. I am sure you all know, we have already done in the first session, the 10% neutral buffered formalin is a fixative. 10% neutral buffered formalin is a fixative for light microscope. This is for light microscope. If I am going to send it for light microscope, the routine biopsy, I am going to say this is a fixative choice. Suppose when I am just going to send for immunofluorescence, I am going to use a fresh tissue. It has to be a fresh tissue sent very quickly to the pathology department. So, you do not put it in a fixative, you send it in a fresh state as early as possible, so that they will freeze and they will do this immunofluorescence stains. For electron microscope, what is the fixative choice? For electron microscope, the fixative of choice, I am sure we already discussed this point in the first session. It is basically 2% glutaraldehyde as a fixative. So, I think we have now formalin as a fixative, fresh tissue for immunofluorescence, 2% glutaraldehyde as a fixative choice for the renal biopsies. So, when I know all these things are there, now I am just going to come and discuss the first thing, how do we interpret renal biopsies. Okay. So, now we will start a discussion. This is a point which I want you to understand. So, electron microscope, the fixative choice is 2% glutaraldehyde, even you can say 2.5 is fine, 2% glutaraldehyde. Now, actually look into the kidney. Kidney is something very important. If you just happen to see the architecture, I am sure you all know this is your cortex, this is your medullary, and this is your calyces, minor, major, and you have your pelvis, renal pelvis, you have ureter, right. So, when you know all these things are going to happen, our primary objective of taking biopsy is from this portion of your kidney, I want you to just look into this portion of the kidney. This is called cortex. So, when I take a cortex will be rich in glomeruli. So, if you want to have adequate biopsy, I should have a cortical tissue for biopsy. Why am I interested in cortex? Because cortex is rich in your glomeruli. This is what happens when a newly joined resident in your nephrology department. What happens when they just poke the needle in the kidney, they enthusiastically poke too deep and get only the medullary tissue. If you have a medullary tissue as only biopsy material, then what I will see is only some medullary tissue showing some collecting ducts. That's all. I will say the biopsy is inadequate. So, that is why it is so important that we have a sample from the cortex. Now, cortex is just roughly 1 centimeters in thickness and the kidney measures 11 centimeters in a maximum dimension and it weighs 150 grams, just like spleen 150 grams. So, you need to know this is the normal dimensions. If you know the normal dimensions, if somebody says it's a kidney is only 6 centimeters, both it's symmetrical in size, which means I can understand it's a symmetrically shrunken kidney. That is what I can understand for chronic glomerular disease. So, understand the normal size, normal weight of your kidney. Now, we will look into the histology. Kidney, I told you, is more often the image based question. So, I wanted to focus on the image. Now, when you see a glomeruli, they look like a flower vase. Can you see that? This is your glomeruli. If you see any circumference, rounded structures, think about glomeruli. Tubules will be longitudinally placed like this, and they will all have nucleus. This is a tubular epithelial nucleus. All these are tubules. If you ask me where is the interstitium, interstitium in a normal individuals might not be very much apparent. Can you see the small intervening white spaces? This is your interstitium. Interstitium may not be seen in a normal individuals. If you have blood vessels, it will be like this, a rounded one. But how do you differentiate this one, this one? In a glomerulus, you find a central tuft of capillaries, whereas in blood vessels, it will be rounded, it will not have any central tuft of capillaries. So, that is the difference between glomeruli and blood vessels. So, when I know this, I think I have identified glomerulus, I have identified the tubules, I have identified the interstitium, I have identified the vessels. So, I think we are on the right track. We now know the 4 areas. Now, we will identify the glomeruli. What is the thing I wanted to identify? We know it's a glomeruli, the rounded one. You have now a tuft of capillaries. Fine. You have identified the glomerulus. Glomerulus is singular. Now, the question is, what is inside the glomerulus? Cells. What is the matrix thing in your glomerulus? That is what is the question. If you know this question's answer, I think we will go on to the next stage of discussion. So, that is what I wanted to do. Now, let us see why it is blue in color, this glomerulus. Very simple. This is a stain called Mason's trichrome. Mason's trichrome stain. It is not a usual H&E stain. That is why it is looking blue in color. It is called Mason's trichrome stain. Now, we will start with the discussion. In any glomerulus, you have 2 things in for glomerulus. One is your cells, the other one is your matrix. We will do that. Let us say I have a cells, I have a matrix. If you know this sort of approach, you will answer many questions in exam. So, that's why I am giving you some preparation for your understanding. The cells can be of 2 major types. If you ask me what are the 2 cell types, there are 2 major types of cells in your glomerulus. So, what are they? We will understand. One is called as endocapillary cells. Endocapillary cells. Then there is another one called as extracapillary cells. I will show all these things, but I want you to first understand the names, then we will identify them in the image. Now, what are the examples for the endocapillary cells? The endocapillary cells are nothing but your mesangial cells, endothelial cells, and also your visceral epithelial cells. How about for the extracapillary cells? Extracapillary cells, we have only one cell here. It is called as parietal epithelial cells. So, these are the 2 things I wanted to know for exam. The endocapillary cells is one, the extracapillary cells. So, I think we have now learned the cells. Now, let us learn the matrix. Matrix is again divided into 2 types. So, now just like cells, 2 types. Now, we will explain what are the types of matrix we have. Matrix can be present in the glomeruli in the capillary walls. We call this one as glomerular capillary wall. In fact, this is what you usually call it as glomerular basement membrane. That is your matrix. What is the next matrix we have? Mesangial matrix. So, I think we have now done with the whole story of the glomerulus. Clues on what are the cells and matrix in the glomerulus. If you just look back in a revision class, what we have done Okay, so I think this is the one we did. The cells, the extracapillary cells, and also the glomerular capillary wall and the mesangial matrix becomes a important cells and matrix. So I think if you just see this, any glomerulus by definition should have cells and matrix. Now we will find out the important landmarks by looking at this glomerulus. Where is our mesangial cells? Where is our endothelial cells? Where is our your parietal cells? Where is your visceral epithelial cells? We will just narrow down everything. It's something which is right in front of you. Only thing is we need to be a little sharper in our observation. So I'll just mark out the points for you. This is your tubules. So this is renal tubules. I think the one which you already made out, tubules. Now we will just figure out some of the important landmarks. Let me just initiate the lines for you. This is your Bowman's capsule. Now you will have some thin walls in the glomeruli. We will identify that as this one. Let me just remove all these things so that we will just start writing on all these landmarks. So now we will start looking at this. So if you just look into it, there are some bluish material here. Like, can we see here some bluish material? We will identify that. Some cells within the bluish material, we call that. Then there are some few pale cells. Probably if you see here some pale cells which are stinging onto the outermost aspect, we need to identify them. And if you are very observant, you can just identify these cells also, right? So we will, so let me just start writing one by one for you. This is your Bowman's capsule. This is your very simple outer ring. What we see here is Bowman's capsule, Bowman's capsule, Bowman's capsule. Now what you see in between, this is small space. Can you see the small space? That place is called as urinary space, or what we call it as Bowman's space, Bowman's space or urinary space. Now in between you see a tuft of material. What is seen here? They are nothing but capillaries. Capillaries which are mangled and forms a ball like appearance. The ball what you see inside, it's made up of capillaries. So any capillaries for by definition will have some endothelial cells in it. So can you see the endothelial cells which are very pale? The one which is pale looking cell. Don't look at the darker one. The darker ones are different one and the paler ones are in the center. So can you see some pale looking cell? That is outside the capillary wall. But inside the capillary wall, if you see here, can you see this is your line? This is your line. Those lines are called as your GBM. GBM or capillary walls. Capillary walls. So that's your capillary wall. Now if you look carefully inside the capillary wall, this is a capillary wall, this is a capillary wall. Inside the capillary wall, you see some darker cells. So even you have some darker cells, but darker cells are right inside the capillary wall. Those darker cells are called as, I'll just write down for you, those darker cells are called as endothelial cells, endothelial cells. So presume within the capillary wall, my common sense says it has to be endothelium. Outside, can you see some, this is your darker cell. Outside the capillary wall, you see some cells which is on the outer layer of your capillary wall. This outer layer cells outside the capillary wall, this is called as your visceral epithelial cells. I will just write down here itself. This is called as visceral epithelial cells. So you have one darker cell, you have pale cell. The darker cell is endothelium. The pale cell is called visceral epithelial. Visceral epithelial cells are also known as podocytes. Podocytes. Then you see some cells in the bluish material. The bluish material is called as mesangial matrix. Mesangial matrix. And some cells which are seen inside the bluish material is called as mesangial cells. Can you see here the pale cells which is seen outside the capillary wall? This is your podocytes, or what we call it as this is what we call it as podocytes. So this is your podocytes which you should know for exam, or visceral epithelial cells. So this is your visceral epithelial cells or podocytes. Now you see some cells. Can you see some cells which are clinging on to the Bowman's capsule? This cells. Can you see these cells? These cells, these cells, these cells. This cell is called as parietal epithelial cells. Parietal epithelial cells. Parietal epithelial cells. So I think we have now narrowed down with the cells what we have in the Bowman's capsule. The cells which are attached to the Bowman's capsule is called as parietal epithelial cells. The cells which are away from the capillary wall is called visceral epithelial cells. The cells which are inside the capillary wall we call endothelial cells. The cells which are seen in the matrix, mesangial matrix, is called as mesangial cells. And this is your lines what we see inside the tuft is called as capillary walls, are popularly called as glomerular basement membrane. Glomerular basement membrane. So you may have the vascular pole, urinary pole. Vascular pole is where the entry and exit of the vascular channels. Urinary pole is where your PCT, proximal convoluted tubule, takes off. So I think that's a simple work on your Bowman's capsule. Now I think now we can identify the Bowman's capsule. This is your Bowman's capsule. This is your parietal epithelial cells. This is your capillary wall of the GBM, glomerular basement membrane. There are cells within these capillary wall, the one which is called as endothelial cells, the one which is seen away from the wall. Can we see here some of these capillary wall, outside the capillary wall, outside the capillary wall, you see, can you see the pale looking cells outside? This is outside. They are called as podocytes or visceral epithelial cells. And the material, can you see some pink material in between the capillary tuft? It's called as mesangial matrix. And this is a capillary lumen. This is your lumen of the capillary lumen. I think we have now narrowed down all these things. For any glomerulus, remember, inside the cells, outside the cells. Inside the cells, we have endocapillary cells. The endocapillary cells are made up of three important cells. Your visceral epithelial cells, endothelial cells, mesangial cells. Now, what about the extracapillary cell? That one extracapillary cell is called as parietal epithelial cells. And remember, there are two matrix elements in the glomerulus. The two matrix elements are your mainly mesangial matrix and GBM, glomerular basement membrane.